Hello, hello everyone. Welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 2536 increment submatrix by 1. You are given a positive integer n indicating that we initially have n by n 0 index integer matrix filled with zeros. You are also given a 2D integer array query. For each query, we have four columns which represents row 2, column 2. You should do the following operations. Add 1 to every element in the submatrix from top left corner, row 1, column 1, and the bottom right corner, row 2, column 2. That is, add 1 to mat x, y for all row 1 less than or equal to x less than or equal to row 2 and column less than or equal to y less than or equal to y2. Return the matrix after performing every query. Okay, let's look at an example. Initially we will be having a matrix with all zeros and we have been given a query called 1122. That means starting at this particular position till this particular position we have to fill each and every element in this square with ones. Okay, the next query is 0011. That means starting at this position and ending at this position, each and every element in this square should be filled with 1. Since this particular element was already filled with 1, we have to increment it by 1. That means it will become 2 and rest everything will be 1. So after performing all these queries, our final matrix would look something like this, correct? Yeah, so this is one more example. If you look at the constraints, n is lying between 1 to 50 and the queries length is up to all the way up to 10 power 4. Okay, we have 10 power 4 queries, and then each the row 1 row 2 will lie between 0 to n, and this is pretty straightforward. Okay, as you can see, that means for all these queries we will have to perform operation on this matrix. Okay, since n is very low, we can actually apply the brute force here and solve this problem. Okay, we can solve this problem with straight away brute force approach. Okay, if you look at the brute force approach, all I am doing is taking the rows and columns for each query. Okay, this is row 1 row 2 column 1 column 2. Once we got row 1 row 2 column 1 column 2, I have to just increment each and every position with 1. Okay, even if you submit this particular solution, your solution will be accepted. Okay, but can we do anything better? Okay, so let's try to optimize our solution. Okay, so let me give an example. Okay, let's assume that instead of having a matrix, okay, let's assume that we only have one single row. Okay, let's assume we have a row which has 5 columns in it and all the elements are 0. Okay, and we have been given two queries 1 to 3 and 2 to 4. That means from column 1 to 3 I have to increment it by 1. Okay, if you see here, column 1 to 3 first I have incremented it by 1, and column 2 to 4 I have to increment it by 1. Okay, column 2 to 4 I have to increment by 1. So since there is already 1 which is coming from the previous query, this will be resultant to 2 2 and 1. Okay, so the final output would something look like this, right? Yeah, so instead of performing the updates for each and every query, can we do anything better? Okay, so if you see this particular query, it starts at 3 and ends at it starts at 1 and ends at 3. Okay, so given a start position, I would first whatever is the start position, I will update my start position with 1 and the end position is 3. So the end position I will update end position plus 1, I will update it with -1, saying that my query has ended just before me. Okay, this -1 indicates that the whatever query which was previously getting processed, that was ended here. Okay, and next we have 2 to 4. That means I have to update my second index, the value at the second index, indicating that a new query has been started at this particular index, and the end position plus 1. Okay, 4 plus 1 which is 5, which is out of 1, so I won't perform any. Ideally we would be having -1 here. Okay, so since it is out of 1, I don't have to include it at all. Okay, Now that after performing these two queries, I know that each query has its corresponding start position and end position in this particular manner. What I can do, I can simply do prefix sum on this particular resultant row. Okay, so 0 plus 1 plus 0, which is 1, 1 plus 1, which will be 2. So here I would be having 2. So again 0 plus 2, so far having result which is 2, and minus 1 plus 2, which will be plus 1. Okay, so this will be my overall answer. Okay, so this is actually, if I have a single row and if I know the columns, the range in which the queries, okay, the queries which represents the range in which the columns in which the column range which have to update. Okay, if we can extend this solution to multiple rows, that means if we can extend this solution to multiple rows, that means it will give you solution on a matrix, correct? So I would do something like this. So for a given matrix, I can say I can take each row and perform the algorithm which I mentioned, and if I perform the same algorithm for all the rows, that means I can get the resultant matrix on a matrix axis. Okay, so let me show you the implementation which I have told. Okay, I have defined a result array which is basically having a dimension of n by n. So initially every element in my result will be zeros. Now for each query, I know what are my rows, what is my row 1 column and what is my row 2 column 2, and as I mentioned, I have to fill my each row with its ones and minus ones for each query, right? So given a query, I have to fill the column position with +1 and I have to fill my column 2 plus 1 with -1, right? So this is what I am doing here. Once I have filled for all the columns, okay, once I fill for all the queries for a particular row, all I have to do is to apply my prefix sum, right? So this is what the prefix sum is. Okay, once I have applied my prefix sum, the final result will actually contain the answer which we require. Okay, if we submit the solution, it should satisfy all the test cases. Let's have a look at it. As you can see, it has satisfied all the test cases and it is pretty efficient as well. Okay, so yeah, before going ahead to analyze what is the time complexity and space complexity for this solution, I highly recommend you to subscribe to my channel so that you won't be missing any content which I am posting on daily basis. Okay, yeah, so let's analyze its time complexity and the space complexity. If you see, I am looping through the queries and then I'm just populating my resultant with the corresponding positions. Okay, so how many queries we have, those many times this particular algorithm will run. So the queries can actually go all the way up to 10 power 4, right? So this is kind of a linear time complexity, and here if you see, we are actually iterating through our entire matrix. So this would run order of n square. Okay, so the time complexity for the overall algorithm would be order of n square for this particular solution. And space complexity, I don't think we are using any extra space other than this result, so ideally space complexity should be order of 1, right? Yeah, that's all about this problem. Do subscribe to my coding channel for more such coding videos. Thank you.